another video. Today we're going to solve page 432, problem number 4. We've got cotan alpha equals -1 over root 3. So the first thing I'm going to do, I don't really want to deal with this cotan, so I'm going to use an identity, and I'm going to rewrite cotan as 1 over tangent alpha. So I'm going to do that over here. 1 over tangent alpha equals -1 over the square root of 3. The next thing I'm going to do is a little trick that you can use when you're dealing with proportions. What I'm going to do is I'm going to take the reciprocal of both sides of the equation, and that's going to leave me with tan alpha equals negative square root of 3. So as you notice, I've come prepared with the special right triangles. So what we're going to try to do is to determine where tan alpha equals. I'm going to look for positive square root of 3 first, and then we'll look around the coordinate plane to determine where tangent is negative, and we'll talk about that in just a second. So if we take a look over here, square root of 3, I'm sorry, not square root of 3, pi over 3. If we look opposite that and adjacent to that angle, we have the ratio square root of 3 over 2 over a half. And if we use our rules for reducing fractions, this is actually equal to the square root of 3. So the reference angle that we're going to use to help us answer this question is going to be pi over 3. So we know that tangent, because of the A Smart Trig class, we know tangent's outputs will be negative in the second and the fourth quadrants. So what I'm going to do is use a reference angle of pi over 3 in the second quadrant and a reference angle of pi over 3, not the scale, in the fourth quadrant. So the first solution to our equation, we'll call it alpha, has to be 180 degrees minus pi over 3. So we're going to do pi minus pi over 3, which is going to give us 2 pi over 3. And then our second solution, rotate over here, alpha, is going to be 2 pi minus pi over 3, which is 5 pi over 3. And if you notice, and this diagram is terrible, it should look something more like this. The solutions to this equation are going to repeat in increments of pi revolutions. So right now we have alpha equals 2 pi over 3 and alpha equals 5 pi over 3. Now again, one way that we can represent the entire solution set here would be to add 2 pi n, where n is any integer, to both of those expressions. But what I'm going to choose to do is to summarize this into one equation. Alpha is going to equal, starting off at 2 pi over 3, and instead of adding 2 pi n, we're just going to add pi n. And again, the reason why is here, if we start at 2 pi over 3, rotate pi radians, that takes us to 5 pi over 3, and then again, those answers are just going to continue to repeat as we rotate in increments of pi radians. So again, answer to this equation, cotan alpha equals